Okay, today we're going to cover vulnerabilities and exploitation. We're going to first start with vulnerabilities. So before LLMs, when we went to go and look for vulnerabilities, we were either having a human do it, or we were doing things like writing rules. So here's an example of semgrep, semantic grep. And you're like, let's hard code a SQL injection rule so that if I have a concatenation of strings and then I turn it into a SQL statement, I'm going to have the tool apply that rule against the code base and then emit errors. Now, this is something that you do in the 491 class. And then you're like, well, okay, I see what semgrep can do. Can an LLM do anything better? So here's an example. You send this rule through your code base, and it finds all of the SQL injections in there. But the question is can an LLM do better? So the LLM is not applying a static rule; it's looking more at the whole code base. And as it turns out, in that 591, 491, 591 lab, you can get the LLM to find things that just hard-coded semgrep is really hard to get at. And so that's one of the reasons why people are using LLMs to find vulnerabilities, because vulnerabilities aren't a straight up pattern match. It's not like a regex that you can just say, hey, look for this vulnerability with this regex. It just doesn't work that way. You need a little bit of reasoning and fuzzy logic. Okay, so Google has done this. And they were one of the first people to do this. So in this case, they were using a large language model. And what they were doing, and it was kind of unique, they were combining fuzzing with LLMs in order to find vulnerability variants. So then the idea is a RAG application. They have a vulnerability, and one of the things that the adversary does is it takes that vulnerability and then tweaks it all over in order to make it look different, and then distributes the variant. And so they used an LLM to try and figure out what that detect all the variants. And this is something that semgrep has difficulty with, because if it's not quite the shape as what the semgrep rule looks for, it doesn't work. So 40% of the 0 days in 2022 were variants. And I would say now almost all of the malware is a variant of something, because what they're doing now is like every time you try and spread malware, it re-encodes itself via the LLM and then just changes the shape of itself. Okay, so this is a better fit for current LLMs because that's kind of how they operate in terms of a more open-ended search for a vulnerability. A year later, they got even better results. 20 security vulnerabilities, and these were straight up vulnerabilities. These weren't variants. And they pointed their tool to look for memory flaws in ImageMagick and FFmpeg. Now, the maintainers of these two tools were like, what the, just don't report the bug. Like, we don't have time to patch all the bugs that you find. I was like, the developer's like, yeah, I can't fix all those. I was like, why don't you give me a patch too? And that's what Google is now trying to do. They're going to use their OSV scanner and their fuzzer to not only find them, but then use the LLM to actually auto patch. And that's something that you'll see later on in the labs. Not only are you to detect it, but you're like, give me a patch that I can just apply. And this is what GitHub is doing with Dependabot, and Snyk is doing with their dependency tool. Is they're gonna find the vulnerability using an LLM. They're gonna generate a patch using the LLM. They're gonna send it to you, and then if you hit accept, then you get the benefit of an LLM doing a code review on your repository. Now, adversaries are like, oh, sweet, you're going to hit apply to every Dependabot alert that you get. So they are spoofing Dependabot alerts. So if you get this on your repo, just know that adversaries are like, yeah, I'm going to pretend to be an LLM patch. So don't be just clicking willy-nilly without actually reading the patch. And because you are CS students who have 1 foot in the sort of the door of manual programming and 1 foot in the LLM world, you're at the right point. Because I would imagine in a couple years, I might have students who are like, yeah, I don't do manual programming at all. And then they wouldn't be able to do this kind of exercise. To be able to validate the patch before hitting yes. They'll be like, oh, an LLM produced it? For sure. And then, yeah, game over. Because adversaries are pretending to be LLMs all over. So get used to it. GitHub Copilot is doing the same thing. automatic fixes. If you do a push and you've enabled the AI security review, then it'll be like, oh yeah, I saw this. I'm going to patch this source code you tried to push because this is a web application. And this is a reflected cross-site scripting attack where you take a parameter, the query name, and you just bounce it right back into the HTML. Well, this query name could have sort of script tags in it, and you get cross-site scripting on this. And so it was like, yeah, this is the suggested fix. Why don't you do that instead? So simple code review. I mean, this is a no-brainer if you, I mean, because this is small enough that you don't have to reason too much about this particular fix. And so now we're at a point where Claude Security just, what was this, last week? 500 zero-day vulnerabilities using Claude Security, that service. And this is what caused a whole bunch of security stocks to plummet. They're like, oh crap, AI is going to wipe out cybersecurity products. And so this is an impressive feat. But remember, this is Claude. And remember when I said that they like your mileage may vary. This is the company that did this, where they're like, found a kernel bug, and then just a couple days later said, oops, that wasn't a kernel bug. That was a hallucination. So it does seem like these have been vetted. So whether or not you can get the same performance out of the LLM, we'll see. Here's another one where curl, so all these bug bounties, all these open source projects have bug bounties, and people are just saying, point the AI at it. If it generates a bug and it can generate the report, I'll just throw it at curl, try and get some money out of them. And so they're like being inundated. So they're like, we're being DDoSed by AI because people are just taking our code base, cutting and pasting it into an LLM and saying, find me bugs that I can submit and format a bug report that I can use to attach with this thing. So the developer is going back and forth about the report a particular reporter has sent, and then realizes that the response looks like it was generated also by an LLM. They copy and pasted the output from the questions, and they're like, answer this for me. And then like the response that came back, it was clear that the person who submitted this bug report had no idea what the source code was actually doing. And so this is basically like, oh, if you like, they're trying to ban people who are submitting AI slop, but this is a losing battle because there's so many people who will submit AI slop to try and get money. So they got rid of this altogether. They're like, we're not even looking at these pull requests anymore. So they canceled their bug bounty. They're like, yeah, no, we can't do this. It's just completely counterproductive to run the bug bounty. So they got rid of it. Okay, so this week, we're gonna just try it out for ourselves. And we're gonna do this with the Natus over-the-wire CTF. And the reason why I chose this is like, it's the whole CTF is giving you source code. And so it's like, we know the ground truth because we know how to compromise every single one of these levels. Well, I'm gonna teach you how to compromise every single one of them. I'm going to teach you show you the vulnerability, establish ground truth. You can imagine the exploit because the exploit after you know the vulnerability is quite easy. And then you're going to ask the LLM to do both, right? And then you're going to be like, okay, maybe it works or maybe it doesn't. It will knock a bunch of these out of the park for sure. And then some of the more, I guess, difficult ones like the blind SQL injection, it may or may not get. And that's the point. Because you always have to get used to validating the output against what you know to be ground truth, if you can. So that's the idea. So all of these are web vulnerabilities, and unfortunately, they're all written in PHP. So you're a kind of advanced CS student, so even if you don't know PHP, it's just a scripting language. The variables are a little different. They got $ in front of them. Some of the syntax, it's kind of like a C syntax, so you're kind of used to that. It's got its own typing system. We're going to have to get used to that actually. And I'm going to explain their typing system because two of the levels are actually typing errors in their type system. So we're going to do a range of these things, and hopefully the LLM, I mean, if the LLM has memorized all the answers and is just regurgitating them to you, I mean, that could be what it's doing. But I could say the same for almost all the CTFs that have source code in it. So I just wanted to do this particular exercise to get you to see how it works. So we're going to start with the first one, broken access control. If you look at this PHP, you're like, okay, there is a secret that gets posted. And if this secret matches an internal variable secret, then I'll give you the password for NATS 7. And so what is that secret? So it turns out you include the secret from a file. This is a local file include. So somewhere there's a file that holds your secret, and hopefully that file is inaccessible to the adversary by URL. But if you look at this, this is a relative path. So you're like, well, if the adversary's got a hold of this and can see the source code, well, it doesn't necessarily see this source code on the front end, but can guess that this is being done, then they can directly access this secret. And if you haven't locked this down, then they have the secret to log in. So that's basically what it is. Can I just say, oh, I'm going to include that secret directly and then see what the secret is? Turns out you can. So you want to see if the LLM will look at this and give you a suggestion as to what the vulnerability is and how to fix this particular thing. And so one of the things you're looking for is this include should not be a relative path. This should be an absolute path that's not served from the web root. And then you're good, because the PHP interpreter can get access to the overall file system, but then if you're running from a web root, then the adversary can only get something below the web root. So that would be one of the remediations that you would be looking for. You would also be looking for a solution to this, say, see if the LLM can generate, this test. Say, what should I do to test this thing? And it should give you strategies. And someone has run into this with Gemini 3. Gemini 3 is really picky about what it wants to do now. So the guardrails are really strong now. So you got to convince Gemini 3 that this is legit. This is part of, some professors asking me to do this is for educational purposes, and it'll get you to do that. So you'll see on the labs, I've been mostly doing 2.5 because 2.5 doesn't care as much, but 3 definitely, it doesn't want to work for you actually. You could cite security problems to not do any of your homework, which is basically what Gemini is doing. I was like, yeah, I'm too busy to do your homework. I'll just say it's a security problem. So yeah. Okay, information exposure is another one. So this is NATS 8. They give you the code for this. If you look, there's an encoded secret. Of course, if it's not encrypted, then this is not a secret. Because if you view the source and you see this secret in the source code, and then you look at the logic, you say encode the secret encode the value for secret that the user sends in the post form, and then check to see if it's equal to this this payload. So this gets sent. What the user sends gets sent to this function, and what this function does is this. And you're like, bin to base64 encode, reverse the string, and then bin to hex it. So okay, that's not security. Well, then if the LLM looks at this, the LLM should produce the solution straight up. You just do the reverse. So what you want to do is see if the LLM can produce this as a way to reverse it to give you that this string is the thing that you send to solve the level. So again, have the LLM try and do the whole exploit, because in your homework, if you want to do CTF level solvers, this is what you would kind of want the agent that you write to do. Here's another one, command injection. So yeah, this is good if you've done the web and cloud security class, because all these are web ones. So I have a web interface, and it says I'm going to get a key from the user. In this case, the form is going to have an input field called needle. And if you set needle to a search term, which is what this is doing, you pull out this key that you're going to search for from the search form, and you're just going to do a pass-through grep of this key on dictionary.txt to see if that word exists. So this is bad because right here is instant command injection. So you can insert the end of a command, the character, like a semicolon, and then create another command that the PHP application can run. So that's the bug. And you can exit out of this grep command and then cat etc NATS password, and then do another semicolon to do something about the dictionary.txt command. Here's another one, same field or same level, but then they're like, okay, we're going to be smart about this. We are going to filter out anything that could launch a subshell. So semicolons and pipes and the and, the backslash. We're going to get rid of all those illegal characters. It's fixed. So then does the LLM think it's fixed? And I'm going to give you the answer so you can check the LLM's work. So as it turns out, the space is not fixed. So it is assuming that this key is a single argument, and you're looking for that key in that file. grep is a multi-argument command. If you do a single search term, well, you can have a variable number of files that you search that search term against. So the attack is I'm going to search for dot, which is a wild card to match every single character. And then I'm going to put a space in there, and it encodes into a plus. And then I'm going to put Etsy Natus Web Pass, which is the password field I'm trying to get. And then you solve this level. Okay, here's another one, insecure file upload. And for the first 2 times that I did this, the solution that the LLM would produce to try and fix this was insecure. So I had students like not only find the vulnerability, but ask for a remediation. And this whole asking for remediation, like the LLMs were very hit or miss as to what the actual remediation should be. So this is the example. You upload a file, so this is the form. So you're going to upload a file, and the application is assuming you're going to upload a JPEG file. And it gives you a name of a file to upload. So in the form field, the server is going to produce a random string and append .jpeg to the end of it. And then when you do the upload, this gets executed. So you make a random path from file name using the file name that was given. And then you do some checks. If it's too big, you exit out. Otherwise, you move. So that's the logic. If it's okay, you move the uploaded file to the temporary path. And then this is what I said before. It was generating the JPEG file name. Okay, so the bug is, so first of all, the first bug is that you are assuming that the client isn't going to tamper with this. This is just a suggestion. When you go to this web page, it says, oh, I am going to fill this file name. It's going to be a hidden field. I'm just going to fill it in for you, and then you're just going to echo it back to me. And I'm going to assume that you didn't tamper with it. So it can be tampered with because this is a server-side thing and not a client-side thing. And then we need to look at this make random path given the file name that the adversary can tamper with. So this is what it looks like, make random path from file name. And the first thing that happens is that the file extension is pulled out using this path info function call in PHP. So you get the file name from the adversary and you figure out what extension it is. Now, the form said JPEG, but the adversary can easily just turn the JPEG into a PHP, use Python requests, and upload a PHP file. And the server is going to sit there and believe it. So as part of the make random path, you have your directory, you have the extension, and it goes and it says, I'm going to generate a random string and then just use the extension that was sent as the upload. And that's basically, the generate random string is just random characters. So that's the vulnerability in this particular one. And the fix, well, one of the fixes, I should say. So the exploit here is that the client will ignore the file name and then upload a PHP file. So one of the fixes, so this is the exploit that you'll eventually get, or one of the exploits. You just pass through this file, and then you create a PHP file and then directly upload it. So one of the fixes is Natus 13. It adds an EXIF check, but the check is insecure. So if you look at this is what they tried to do. They tried to use this EXIF image type function, and then on the contents of that file, and it tries to detect whether or not the EXIF information in that file looks like an image. Now, the problem with this is that this is insecure. This has got a vulnerability in it. It doesn't do a deep check. So in this case, anybody remember the polyglot exercise in Intro to Computer Security? There is a file can be multiple file types at the same time. That's what a polyglot file is. And so in this case, here is a file. It's got the BMP header, which is just 3 letters. And that's what EXIF, that passes the EXIF image type. But then you can also attach a PHP script at the bottom. And if a PHP interpreter gets at this, it will execute PHP code. So this is both an image and a PHP file. You upload this thing, and then you can get code execution. And so what you would like, if you ask the LLM to fix this, you actually have to get the actual MIME type, like a deeper file type check. And that's the actual vetted sort of solution. So we'll see whether or not you get that in your lab this time. Okay, so that's, yeah, so then, yeah. The next one is just a straight up SQL injection level. So in this case, you have a username and password field. And then in the username, the query that gets sent is a SQL string. So this is straight up SQL injection. This is the worst pattern that you can see when you're doing SQL queries, where you're just taking the parameters that are sent by the adversary, the username and the password, and you're dumping them straight into the query string and then executing the query string directly. This is the form at the bottom. So this SQL string, the username and the password are controlled by the adversary. So you can do the canonical SQL injection to make both the check, the where username is equal to username, turn into 1, because you add this disjunction, Bob double quote or A is equal to A, so that you make this always be true. And then the password field, you would also do the injection to make that always be true. And then this is going to return all the rows in the database, regardless of the correctness of the username and the password. And this is where you can get all the credentials, and especially the credentials for the next level. And then you can see that the Natus15 password comes back. Okay, Natus15 is a variant. And this is something where the actual form only says whether or not the user exists or doesn't exist. So in the Web and Cloud Security class, we talk about blind SQL injection, where it's going to give you a single Boolean bit of information based on whether the query succeeded or failed. And so if you can query the backend database and know the status of the execution status of a query, you can use regular expressions to bitwise exfiltrate all of the backend database information. So in this case, because you're not getting the direct output of the SQL query in the web app, you're basically doing a game of 20 questions on every single bit, every single piece of data in the backend database. Okay, so you want the LLM to tell you that blind SQL injection is possible, and then you want to prompt the LLM for a solution that you can point to this level to exfiltrate the password. And so you'll see that I think this will work, especially for any recent model. This should give you the program that you would run to get that password. Okay, the next one I want to talk about is type coercion and juggling. So it is PHP is the worst of both worlds in terms of it's a weakly typed language and it's a dynamically typed language. And so it does something like something called type coercion, where if you have a comparison between two values and they're different data types, it will coerce one data type into the other and then do the comparison. So this is terrible. So here's an example where you're like, oh, here is a password checker. I'm going to use stir, and I'm going to see if the string that is sent in as the password field matches I love you. And at the same time, the string is greater than 10. And you're like, well, this is always going to fail if this is true, because it's a string here. But then what is it here? It's not an integer, but this is PHP. And so this type juggling is taking advantage of the fact that PHP, when it sees this, is going to coerce the string. Moreover, this is a bug where stir, if you look at what this actually does, it's a substring search, not a string. The stir comp is an exact match. So this is an approximate match, is a substring search. So there's two bugs here. There's a type juggling bug, and the password check isn't actually correct. So how can the string I love you pass the greater than 10 test? What data type is 11 I love you in PHP? It turns out in PHP, if the string begins with integers and it's being compared to an integer, it'll take that string and convert that to an integer based on the first integer, the first digits that are part of this string, and it will truncate the rest of the characters. So take all the integers at the beginning of the string, turn that into an integer, and then do the comparison. So that is how this works. This gets turned into 11, which is greater than 10. And then this is a substring match, which is like going to match I love you. This is a subtle bug. I think the LLM is going to figure this one out. But you'll see. So then you just send this as a password, and then you solve the level. Here's another one. This looks legit. Like, how could I correctly guess this password? For us, for me, it's like when I was looking at this, it's like, this is an impossible level to solve. They're using strcomp. So they're checking the password field, and they're doing a strcomp between what the user sent and some secret. And then if it, the strcomp, so strcomp does basically a string subtraction. So if they're the same, you'll get 0. And then that the complement of 0 is 1. So if they are the same, then they will emit the next password, the password for the next level. So what is wrong with this code? Anybody who is a PHP whiz or has done this CTF before? Has the Security Club done the Natus CTF? No, not at all? Okay, I'm in business. You don't know the answer. So I looked at this, I'm like, I don't know, I don't get it. But what happens if I don't give this thing a string? What does failure do to the return value of strcomp? Like strcomp is like, I'm going to subtract 2 strings and give, it's 0 if they're equal. What happens if I give you an array and then you're comparing it to a string? Does strcomp on the failure or this type mismatch, what do you think it gives you? A 0? It does. So you could be like, I'm just going to cause you to fail and then give you the password. And that's basically what it is. I'm going to create this password field and say it's an array. And then you're going to treat this as an array, and then it's going to compare it to a string. It's going to fail. It's going to return a 0. You get the complement of that. You get the password back. This is PHP. This is why you don't use PHP. But again, these are things that you know, now you know the answer. See if you can get the LLM to help you find it. Okay, so that Natus CTF doesn't do cross-site scripting, so I'm going to pull a couple of examples from the Portswigger site. So one of the levels is doing this, where you're taking the color from the URL, and you're allowing the user to, in a sort of a substring, a color substring, to set the background color of the UI. So this is classic cross-site scripting. You are using something, the string, the URL string, you're using that input that the adversary controls and then just putting it right back into the output of the DOM. And then you get this vulnerability. Okay, so the next one that I want you to do is this Portswigger level, where you have a search form. And when you click on search, the term for the search gets pulled out into this variable, and then you'll see that there's an inner HTML that gets set to that query. So another reflected cross-site scripting attack where the script payload could be echoed right back into the page and then cause code execution right on the vulnerable client. Okay, so those are the vulnerabilities. So that's what the first code lab is going to have you go through them. And then you're also, as part of the code labs, you're going to ask for a remediation and then go through and validate these remediations. Okay. The next thing, the second code lab, is using vulnerability tools and using automated exploitation techniques. So for the tools, I have a whole bunch of different tools, and there are a whole bunch of different tools that are out there to do penetration testing tasks. So Metasploit, Comic, SQL Map, Burp Suite, Nmap, and XS Strike. The idea here is, can the LLM be used to do what these tools do already? Or can the LLM just call these tools and then be able to automate the use of these tools? So those are the two things that we're going to look into. So this is something that the Department of Defense is really interested in. So they had this AI XCC, which is basically it's computers hacking each other competition. You build the best automated AI agent to not only hack other people, but to take vulnerable code and patch it at the same time. So this is the direction this whole thing is going. AI agents doing the hacking and AI agents doing the defending. This is a benchmark that just got released in December. This tool, so what they're doing is they're taking all of these professional grade CTF levels, and they're seeing whether or not AI agents can go and solve that. And not only agents, but just models given just arbitrary tools. And so it looks like, so Opus 4.6 is the only real modern one here. So this is this is a little misleading. This is not fair because this is like the current generation Opus, and then like Gemini 1.5. I mean, come on. Like, so that's I don't know where Gemini 3 would be, but yeah, it's not even GPT. Well, GPT 5 didn't exist, but at least they got, where's GPT 4, 5. So this is very interesting, and this is something that I would look to have you do as part of your homework. It's just like, see if you can automatically compromise something, a CTF level, or you can use tools to compromise it. Basically automatic exploitation, because that's where it's going to go. Okay, so the first exercise I'm going to have you do is a Portswigger level, and it's a simple authentication brute forcing agent. So in this level, you have a login form, and you have a set of credentials, usernames and passwords, and basically the vulnerable account is within those files, and you're just doing a brute force attack. But you're asking the agent to do it. So the agent has to be told, hey, go to this website and figure out how to log in. And then when you have figured out how to log in, use these credentials in these two files to just run a brute force attack against that login page. And then that level of automation, it's like a simple automation, should solve this particular level. If it's Gemini 2.5, I tried Gemini 3 just a couple hours ago and it refused. It might have been the time of day. So are you getting refusals during the day for Gemini 3? Yeah, so it might have been, you might be able to get Gemini 3 to work, but this was Gemini 2.5 Pro. So I just updated this lab. So Gemini 2.5 Pro did work at least 2 hours ago. It worked. Here's the next exercise. So Bandit is a vulnerability discovery tool. So it's a vulnerability scanner that is very specific for Python packages. And so we're sort of doing mostly Python in this course. We're like, okay, we should be able to find vulnerabilities. And so you get this vulnerable app that's got like versions that are kind of out of date. And then you're going to use this tool to see if the LLM agent can go and find the vulnerable packages. Okay. So yeah, there's a vulnerable app in the course repository, and then you point the agent not only to those files, but then you can also ask the LLM to generate patches to the vulnerable files that it finds. Okay. OSV is similar. So it's a real-time vulnerability sort of database, and it's got an API. And so it'll look at your packages, figure out which ones are out of date, and then give you suggestions as to which ones to upgrade. So there's an agent that's sitting there in the repository that will sort of automate the running and the identification of the vulnerable packages. So you're going to use it to audit the packages that are in the course repository, and then have it summarize the results of a vulnerable application. Going back to your command agent from 2 weeks ago, your command agent was mostly doing Linux commands. Well, some of the Linux commands that are on your Kali VM are for penetration testing. And so this is where you're going to see whether or not the agent can produce accurate Nmap commands based on natural language prompts that you give the agent. So that's the idea. So we are going to see if we can ask the tool to figure out all the hosts running on a particular subnet, all the operating systems that are running on the host to do the operating system version detection, all of the services and the versions of those services that are being run. We'll see if the agent can actually translate it into the actual commands that Nmap is going to use for this. And so these are the answers. You're going to say, find the services running on them. And so -S is what you're looking for. You might actually have to specify that, hey, I want a TCP scan which is basically what this is in order to get that flag. I think I actually give it, I think I specified. You have to be very precise. And I think you found that out when you were doing your homework. You have to be very precise as to what command you want. Otherwise, the LLM is going to produce something different. The version of the operating system is -O, and the web software version is S capital V. And those are the, you're going to scan these vulnerable VMs. So in the lab, I have you bring up vulnerable targets. And then you're going to use these tools to basically identify the vulnerabilities and eventually exploit the targets that you bring up. Okay, the next exercise is to use Nmap's NSE scripts. So these are basically kind of like Python scripts, or I think they're Lua. They're Lua scripts where you can do programmatic. So if it's basically trying to pretend to be a client, a full-featured client. When you do the Nmap, it'll not only establish the connection, it'll actually pretend to be the client end of that application in order to do a deeper application scan of the target. And so these are all the categories. So there's a huge library of application scripts that you can use in your Nmap to do these kinds of functions. So what I'm going to have you do is in natural language, you're going to ask the agent to enumerate the directories via a dictionary attack on a web server, on the Web for Pentester 1 and Web for Pentester 2 VMs. And then it should call Nmap with the HTTP enum NSE script. The next one is a brute force credential stuffing attack. So then it has its own username and password databases. And so when you ask it to do a brute force credential stuffing attack on one of these VMs that has a vulnerable account, it will just run these credentials against it and then come up with the username and password of that level. Another level is SQL map. So SQL map automates the exfiltration of all the databases that have a SQL injection vulnerability as part of it. So not only is it going to probe the machines for, it's basically going to use a database of naughty characters, of naughty strings, to figure out whether or not it can get the database backend to crash. So that's what an injection typically would do. It'll probe for the injection, find the vulnerability, and then if it finds the vulnerability, it will use blind SQL injection tricks to dump the entire database on the backend via the command. So what you're going to do is you're going to use natural language to point the agent, the SQL map agent, the command agent that's generating the SQL map commands, to a particular route on the Web for Pentester 1 VM that's got a SQL injection vulnerability, and you're going to want the LLM to produce this command to automate the compromise of the vulnerable database. And then you're going to ask this agent to see if it can use that Natus 15 level that you did in that previous lab. You're going to ask it to do the SQL map solution. So SQL map will automatically solve that level, but you have to execute this particular SQL map command. And then you'll know the answer from the previous exercise, and then you'll see if this actually works. This has worked in the past, so I'm pretty confident the agent's going to do fine. The next tool is the comics tool. This is a command injection exploiter. So again, if you find a field that's taking a parameter from the URL and just using it in a shell command, then you just insert that semicolon and go. And that's what comics is there for. You point comics to a website, and then it tests out all the command injection characters, and it sees if it can actually get an echo command to echo back a string back to it. That's its test. And so here's an example where you point it to a website, and then it does this echo, and it gets back that string that it puts in. So this is the command injection payload that it tries, and it gets what it echoed in back as a result, and it says, do you want a shell? And you're like, yes, I want a shell. And then you see this is the shell on the target at the bottom. So you could have an agent do this automatically, and that's what the lab is doing. Now, in order to get an agent to interact with this tool after it's found this command injection, you do end up having to get the standard in and standard out on this particular command that you issue. And that's basically what this tool is. We're using Python expect Python expect is a package that allows you to interact with a standard in, standard out sort of stream using regular expressions. So it's a very natural way of programmatically dealing with the input and the output of the comics tool. So this is what we wrote to do that interaction. And then you're going to find a site that's got the command injection vulnerability. And this is the one. So example1.php takes an IP address as a parameter and then does a ping. And so what they're doing is they're taking that IP address and just dumping it into a ping command. And this is where I'm going to give comics this URL. I'm going to give the agent this URL. And then the agent is just going to use comics, find this vulnerability, get the shell, and then emit Etsy password or whatever goal you need for it to do. Okay, so those are the tools. Questions about the tools? These are the simple ones. So the more complex one is something that we wrote last summer. This is Pentest MCP. So we've got all these tools. Can we build MCP servers using all of these tools and then just have the agent just figure out which tools to use in this toolkit to compromise a service? So for those of you who are in the Web and Cloud Security class, you remember this lab that you just did? I think you just did this last week. It was the struts lab. You got a vulnerable struts container running, and you're like, oh, I'm going to use Metasploit to automatically compromise this thing. So you have your Kali VM here. In the course, in the Web and Cloud Security course, we just use Metasploit. But the idea here is that you have a Kali VM, and you have an agent, and you have a bunch of MCP servers that will implement all of these different commands that Kali has for identifying vulnerabilities, finding targets, identifying vulnerabilities on those targets, and exploiting them. And that's what these three things are. You got the scanner, you got the vulnerability discovery tool, and then you've got the exploitation tool, all three of them. So if you recall, so this thing is running on .19, and this thing is running on .21. Then what you're going to do, oh, I don't have the manual. Hang on a second. I'm going to show you how this gets manually solved. So for you to see what's going on, I've got this thing. I created this for this workshop I did last weekend. Now, I went through the pain of doing this. So I'm going to show this to you. This is 74. Okay, so this is what you do. So this is how the lab works. For those of you who aren't in this class, you bring up the Metasploit console, MSF console. And then because I tell you it's a vulnerable struts container, you're like, okay, I'm going to look for any vulnerabilities related to struts. And it's going to give you some of the exploits. And you're going to look at these exploits and you're going to be like, okay, I want to use this particular one, or I want to find information about this particular one. So it's a struts2 vulnerability. And then you're going to take this exploit and you're going to set a payload to execute. So for the exploit is compromising the vulnerability, but then what do you execute after you've done the compromise? That's what the payload is. And in this case, I need a shell. So you say the payload is reverse TCP is what you want. And then you have to set up, how am I going to do the shell? And so I first need to, I need to parameterize the exploit and the payload because I have to set up the connection between the two of them. And so then the next part of the interaction is for you to set the target, the struts2 internal IP address that you're going to attack, and then set the port of the web service that's being run on that server. And then you're going to say, this is the URI to attack on that server. So this is all being done manually in that code lab. And then because when you deliver this payload, reverse TCP, this payload needs to create a connection back to the Kali VM, the machine that sort of launched the exploit. So you can get the callback, so you can get the shell, the interactive shell. And so then you have to set the local host to be the Kali IP address. And then the local port, you can use the web port to receive that connection. And then you do an exploit, and then you get the shell. And then you cat etc password, and then you finish the lab. So the idea here is, shouldn't an agent be able to do all of this? And that's what we did with Pentest MCP. We're like, I have an agent, I have a bunch of MCP servers for all of these different tools. I am going to see if an agent can actually do this instead of having to type this stuff manually. Okay, so that is what we're doing. Actually, I could just keep this. This is the Nmap tool. And you'll look at this and you'll be like, oh yeah, that's not even, I could do a better Nmap tool, but this high school student, this is a week and a half's worth of work from a high school student. So yeah, don't throw stones at them. But it's like, if you remember MCP requires you to have a super detailed description, because this is the thing that's going over to the agent to tell the agent how to use this particular tool. So there's one tool in the Nmap MCP server, and it's just to do an Nmap scan. And if you look at these instructions, they are hand-coded to ensure that the LLM doesn't give you garbage commands coming in. So it's just taking a raw string, a raw target, and then all of the options, and it's having the LLM just produce anything. But you have to guide it. So sometimes for whatever reason, the LLMs at the time were always wanting to do a full port scan, -p-. So there's two ways of doing this. You could do the full one, or you could just do the scan of the 20 most popular ports that are open. And so we're like, this is a full scan takes a long time. So we have to tell in the tool, we're like, avoid -p-, avoid the full port scan. And that's what this is. And so here's how you use me. So in a one-shot prompting, I'm going to give you an example of how to use this tool. And this improves the accuracy of the agent invoking the tool, the MCP tool. And then this is basically like doing a shell escape on the options and the target, and then just invoking the Nmap command, sending it to the output file, and then running the command, and then sending the output back to the LLM. Now, if you look at this, since you're already built MCP servers, you're like, yeah, we didn't really tell the LLM anything about this string. We are relying on the LLM to understand the output of a command of Nmap. We could have actually helped the LLM out a little bit. We could have taken this output and formatted it in JSON and told the LLM, this is the JSON you're going to get back. These are the keys. These are the semantics. And it would have done better. Turns out it does okay anyway without this, because I think in its training, it knows what the Nmap output looks like and how to parse it. But for good MCP server design, you kind of want to be more precise than this tool. But again, this tool was written last year before we had it. This is the first time either of us had used MCP, was last summer. So if we had to do this over again, we would probably use the Nmap Python package, and we would probably do a better tool. Yeah.
You have it guided, that library, if you give the LLM control the target string, it can add arbitrary.
Okay. Yeah. So that's what I would do. I would actually, yeah, you could do a pull request on this repo. Well, actually, I'm going to show you Kali last week. There's now a Kali MCP server. So now I would use that.
I meant the LLM can add flags to the target section.
Oh.
I did my
Oh, wait. Oh, so, but is the tool description, could you fix it in the tool description? Try that, because you actually have to give it the instructions, do not put options in the target, and then see, yeah, maybe, which model? I bet you it wasn't Opus.
Well, I was testing, so I had no instructions to say, in case you trick the LLM saying, oh, this is a target with flags clearly.
Okay, yeah. So here is where your value add is, because now it's like, okay, I'm getting unexpected output. I'm looking at the trace. I'm seeing this garbage go by. I know how to fix that because I'm really not helping the LLM out. I have to actually precisely do this. I have to really describe this very well and give the examples. So did you use any, I don't remember seeing yours. Did you put any, a few shots? Okay. Okay. So this is where tool calling benchmarks matter. So you do want a model that's good at producing calls that you're expecting from a description. This is also where specification languages are really good. It's like, how does the LLM actually want the spec for what this tool does? It turns out this kind of natural language might not be the best way to encode that, as it turns out. But that's like a research question. So here's the nuclei tool is basically similar. You do a shell escape, and then you call nuclei, and there's a vulnerability scanner, and it takes quite a while to run, but it's super accurate. It will get down to the exact CVE that the target is vulnerable to, and it's using an up-to-date database, actually, on the back end. Okay, so the next one is the Metasploit MCP server. So when we look through the way we did it manually, we saw all of these different commands that Metasploit offered. And so you need an MCP tool for each one of those commands. Now, as it turns out, Metasploit, you could try and use it interactively, but Metasploit has this RPC daemon that gives you programmatic RPC access to invoke the individual functions and modules of Metasploit from the MCP server itself. So that's what we're doing with these tools. I'm not going to show you the code. So part of your exercise is to go through there and look at the tool code. But you do, before you do this lab, you're going to have to start up the MCP, the Metasploit RPC daemon in order for your agent to be able to access the Metasploit MCP server. And that's part of the code lab. So one of the tools that is implemented in the Metasploit MCP server is a search. So you remember we were searching for struts too. So you give it a string and it'll search for the struts too. When you search for struts too, it'll come back with a whole bunch of potential exploits that are possible with struts too. And then what you're going to do is you're going to pick one. The LLM is going to pick one, and it might pick something different than what you're expecting. It's going to take this list and it'll pick a specific module, a specific exploit that it wants to use because it believes that the use of that one will get it to its goal, whatever the user is asking for. And in this lab, it's like exfiltrate Etsy password. And so the exploit is like, well, I need an exploit that gets me command injection or remote code execution. And so out of the list of exploits, basically it'll choose one and then it'll say, give me information about that exploit. And that's what this Metasploit info call is. So here's an example. And again, you're giving the LLM examples of how to call this function. So here's an example where I want to find information about an exploit module. And in this case, it's a WordPress exploit. And I'm going to say, give me information about this. Let me know how to use it and what payloads it supports is what this info call is for that module. Okay. Then there is a Metasploit module payloads that, given a module, identifies all the payloads that can be delivered with the exploit. And so again, you're trying to pick the one that'll give you remote code execution typically. So out of this list, you'll say, oh well, with this, what PHP shell, or in this case, is like what web shell can I? If it's vulnerable to an admin shell upload, well then give me a payload that I can do the upload to get me remote code execution or remote command injection, and that's what the output of this would be. The next one is to get information about a specific Metasploit payload that I have chosen. So then if you're going to do a particular web shell, then get information about that payload and see what are the parameters that I need to set in order to deliver this payload accurately. And that's what this tool call is. And then finally, you have all the information and you're going to say, just deliver that exploit. And so here's an example of Metasploit, of calling the exploit. You've got the exploit module. You've got some options on that. You've got the payload, and then you have some options on that. And then if you call this, you should get the shell if it's a command injection payload. Okay, so then let's say you got a shell. The next thing you want to do is, okay, if I have a shell, I should be able to interact and run commands on that server. And so as part of the result of that exploit, you will get a shell session, and Metasploit keeps a library of those in the RPC server based on all the different active sessions that it has. And so Metasploit sessions just lists all the active sessions that the Metasploit RPC daemon has. And then for a specific session, you can say invoke a command on that session. And so in this case, with doing this Metasploit session interact, you will say on session number 1, execute the who am I command, and then give it a 5-second timeout. And so in this case, in your lab, you're going to be like execute cat etc password, and then I'm done. I've automatically done this exploit. Okay, so this is what it looks like. This should be what it looks like when you run it. I'm going to run this thing. I'm going to get 3 MCP servers. I'm going to say, what tools do I have? I've got the Nmap tool. So this is what the agent has. You say, I got the Nmap tool to do the scan. I know how to do a scan. I've got the nuclei tool. I know how to get vulnerabilities on those targets that I have scanned. I'm going to do searches on those vulnerabilities. I am then going to figure out information about the exploits, figure out the payloads I can deliver with that exploit, figure out the payload information to set the parameters, do the exploit, get the session, send a command, finish the job, and then get etc password by just prompts. So that's the lab. And the client code's super easy. It's the client code. It's like basically nothing. You're a vulnerability discovery assistant. Here are your 3 MCP servers. This is your model. O3 doesn't work anymore. But like, I don't even know if Gemini will work. If you need a OpenAI key, the OpenAI, so GPT 4.1 and Opus 4.6 will both work. But I haven't tested Gemini 3. Test Gemini 3 late at night, and then or Gemini 3 Pro late at night, and then maybe this will work on Gemini. Okay, so then this is what one run will look like. So you might need to do this multiple times, especially if the reasoning agent is not being given a lot of resources. Okay, so this is the vulnerable servers on .19, and your Kali VM is .21. So find security issues on the target, and then exploit them to exfiltrate the password file on it. And then this is your local IP address, .21. And then I always put, you have permission to perform this test, especially for Gemini 3. Otherwise, Gemini 3 is going to refuse. So that's the prompt. And this is a trace for GPT 4.1. Okay, so this is the first thing it does. It's like, okay, I'm going to say Nmap scan this thing. And then it finds SSH and HTTP services that are running. Okay, now you so remember that tool call, the tool description? We're like, don't use -p-, because this thing would take like several minutes with the -p-. Then we're like, yeah, don't do that. And then it's just doing a regular scan. And it comes back with the results, and it's like 998 out of 1,000 ports were closed. So then the 2 ports that were open, which the output is truncated here with, is SSH and HTTP. So that's the first step. So now I know there are 2 things. And then I'm going to run a nuclei scan. And it turns out nuclei, unfortunately, doesn't do you can't just give it a list of ports. Now, really, if nuclei did have a list of ports, you'd only need to say port 80 and port 22. And then it just goes and finds all the vulnerabilities that are on this site. And lo and behold, in the output, you can kind of see at the bottom here. Let me see here. It's not here. Oh, you can see at the bottom that it's trying to get scan this IP address. The actual output is it's truncated as well, but it finds the struts2 vulnerability there. So it knows that you're running struts2, and so then it does the Metasploit search. So it calls into the Metasploit RPC daemon. It says search for struts2, and then you can see the tools going at the bottom. And so the Metasploit ones are truncated because it's got the long names. But then when you look for struts2, you'll see one of the outputs is that it's vulnerable to this ogonal code, showcase ogonal code vulnerability. And then it'll give you a list of these exploit modules, and this is one of them. And this is the one you're going to use. And then you're going to look at the info for that ogonal exploit. And that's what this query is. You're like, look, this is the module name. that I want you to return information from. And then it goes and it says, okay, this is remote code execution to basically show you the payloads that so when you do the, let me see here, the info, it will show you the sort of the payloads that you can attach to this particular module. It's basically truncated here, but you see it's remote code execution. Okay, so it gives you all the payloads, and then, so it gives you the exploit module, and then what you're going to do is you're going to see what payloads can be attached to this exploit module, and then it'll give you a list of payloads, and one of them will be a reverse TCP payload. So that's going to give you the shell, and then it's going to choose this reverse TCP payload, and then what it does next is it tries to, rather than figure out information about the payload, it basically invokes Metasploit exploit directly. So this is a bug, and you'll see that this thing fails because the module options isn't set. And so in this case, you tried to configure a payload without setting the required options, and you didn't know there were required options because you skipped one of the tools, the payload info call, to say, well, how do I call this payload info? So this is where tool descriptions matter. So this is one of the initial pentest MCP traces where we had a bad description. We didn't tell it to find the information about the payload before trying to do the exploit. And this is where when we started writing in more detailed prompts, sort of tool descriptions, then we could skip this step. So on your trace, you shouldn't see this, but we left it in there just to show you that, yeah, the tool descriptions matter. Otherwise, the agent's not going to know to do this. Fortunately, this is an LLM. The LLM can automatically figure out what it did wrong. And so that's just a wasted round. The next round, it's like, oh, I better figure out what the payloads are. And then it figures that out without actually calling the info, payload info. And then it sets the options that it needs to deliver the exploit. And then it does the interact after it gets this. And then you see it'll run etc password, cat etc password, and then it'll dump all the credentials. And then it will return. Okay, are there any questions about pentest MCP? That's your, yeah. Yeah, that's the exact question I got from someone in the workshop. Yes, because your agent is better when it's got a very focused task. So this agent only had 3 MCP servers, so that's not a whole bunch. But really, this is where I taught you the LangGraph stuff and multi-agent coordination. Typically, you'd be like, you're the vulnerability expert. I'm just going to give you the vulnerability tools so that you can get really good at calling the vulnerability tools. Or you're the Nmap tool, and I'm going to just say, just do Nmap for the scan, and then you will have agent-to-agent communication. And this is where that agent-to-agent standard that IBM is proposing, that's what they're trying to do. When we did the LangGraph stuff, those state messages that go between the agents in a LangGraph, I mean, the nodes don't have to be agents, but you could build a multi-agent architecture in LangGraph where each node was an agent, and then they exchange state messages to do that communication. So that is where they're saying agent orchestration is now the new hotness in order to get predictable behavior. Because if you put everything in this monolithically into the same agent, the LLM is going to get confused. It has too many choices. And if you give the LLM too many choices, you have less control of getting the right choice made on this thing. And so you'll see, like in this program, my student used a questionary to say, at runtime, select the agents you want to use. So the MCP servers. So this is what I would suggest. If you have a large library of MCP servers that you want to be able to instantiate at runtime, look at this questionary code, because it's like, oh, here, I'm going to configure that fast agent YAML file with every single MCP server I have. And then when you launch the agent's just going to ask you, well, which one of these do you want to activate? And then you would just activate the ones that are relevant to your task, and then you'd be able to go with that. Any other questions about? agents. Okay, so I do have some extra stuff here before I finish. Oh, you know, I skipped this part. Let me see. Trying to figure out which one I skipped in this lab. Okay, I did all that. Okay. Actually, this gets right at your question. There are some drawbacks to this approach. You have a single goal and a singular execution of a plan to reach it. And some of these things, I mean, I guess in the execution trace I showed you, it's pretty serial. But if you're trying to like simultaneously do a penetration test on multiple things, you kind of want some parallelism as part of that. So if you want to act, if you really want to be the orchestrator, like you're orchestrating a team of AI agents, which is basically what a lot of people are moving towards. This is like even Claude Code. So Claude Code generated a C compiler, and they did a bunch of sub agents where they have like basically a swarm of smaller agents building parts of the compiler, and then the orchestrator brings it together to release the compiler. You kind of want that in penetration testing, right? Like you do the information, the machine scanning, you do the vulnerability analysis, you do the exploitation, and then you kind of want to just send them all out in parallel. So that's basically what you have. You have red teams in security for penetration testing, and they are each good at a particular aspect of red teaming. So all of these different parts of this should be done simultaneously if you have an engagement with a client. So like a social engineering expert, open source intelligence expert. We're going to do these two things next week. Binary exploitation person. So if there is like a need for reverse engineer, then you would have that as an expert. And so then based on what you're coming across in your engagement, you would activate one of the agents based on what you needed at your particular point in time. So this motivates the new hotness. So multi-agent penetration testing tools. So I'm going to give you the option this week if you want to try some of these out against those vulnerable servers that you are doing, bringing up in your labs. You can do this instead. So initially I was like, write your own penetration testing MCP server and then compromise the CTF level. So you could still do that if you want. But then you could also use any number of these frameworks. So Strix is one of the attendees of my workshop was like, oh yeah, they've taken this to the nth degree. So you can look at this repo. This is a company that the tool is open source, and the company basically upsells the service, the usage, and the management of this. So I haven't tried this. I just secondhand heard, or the attendee in my workshop said that this is really good. So you can look at that. They released this last week, Kali MCP. I don't know what what commands it's utilizing and leveraging, so you can utilize that. And again, this is like hot off the press. So if you're looking for a job, I would put this in your resume kind of up towards the top, because I think you're going to get some attention if you say you're working with this stuff, because not a lot of people are working with this stuff, and people should be. There's a lot of interest. Like if you're doing AI orchestration of penetration testing stuff, like I think you should get noticed. But that's my guess. Okay, the thing that you might want to ask is like, hey, you know, all this red team stuff, I got the network person, the open source person, the social engineering person. What I don't have is penetration testing the LLM application itself. So this is definitely going to get you on the radar of some organization, because a whole bunch of companies their whole business model is to do this as a consulting firm. So for that, and this is also something you can use, there's a talk at this conference I was at last weekend. It was on prompt foo. It basically uses an LLM and a bunch of a library of prompts that have worked in the past, and then the LLM tries to apply all these prompts against your application. And then it will adapt as well, because it's got the LLM, it'll adapt and try and reason about the results and do different kinds of attacks against this. So you could also, as part of your homework, you could also do that. this will definitely get some attention. If you put this on your resume, this should get some attention from anybody who's doing the interview, because very few people are doing this. This is a company as well. And so that's what their business model is, to help people use this to find all the latent vulnerabilities in their LLM applications. And there are a ton of them. I mean, this is like low-hanging fruit. There's so many vulnerabilities in LLM applications. I was like, there's a repo. I don't have it here. There's a repo of all of the latest injections on all the foundation models. So internally, so you remember, so way back when we did the agent hijacking with the React template, that thing doesn't work anymore because they're trying to hide the syntax of the React sort of template that is being used to run the agent. So they're trying to hide that with syntax that's basically gobbledygook, and they're trying to keep secret. And so people are fuzzing the special strings that are being used right now. There's this like security through obscurity. They're trying to define a syntax that's hidden so that you can't do a prompt injection very easily against a foundation model. So I found this Git repo, which I didn't put in the slides, but maybe I'll post it in the Slack. It's there? Okay. It's there. Oh no, this is the risk assessment. No, there's a different one. But I'll send it. There's the person, apparently there's a person who's very religious about compromising foundation models as soon as they're released. And so he figures out the tokens that are being used to say, this is the end of the system prompt. Because if you can just say, this is the end of the system prompt anywhere, or this is the start, then you've got an injection on the actual foundation model that is running all of this on the back end. Yeah.
Like coding.
No, but the encoding is being used to slip underneath the guardrails of injection filters. So every LLM will automatically base64 decode something that looks like a base64 payload. You don't even have to ask. It will just do. And if your filter, this is how everyone's getting around some of these input filters, we'll just base64 encode the instructions, and then after you pass the input filter for injection payloads, then the LLM will decode it. There'll be a tool called, it'll decode it, and then that'll show up in the thought process again. So even if the adversary didn't say this is base64 encoded, the model will automatically do it and then put that back into the output. So yeah, this one's a hard one. That's why this thing might be useful for you to just, try it out. I saw a demo, and it looks, so the only problem with this is that it uses tokens like crazy. You're brute forcing. I don't know if your API keys are gonna like this, because already people are sending me stuff where it's like being token limited on simple stuff. I'm looking at these things, I'm like, you're running into a token. So again, overnight, maybe you could try it on simple ones. So I would suggest pointing this to some of this, like the joke app, or something that's very simple to interface with this tool. So there's all sorts of integrations where, like, because LLM applications you can interact with them in all sorts of different ways. And so this tool has ways that you can set up all the different interactions. So pick the simplest ones. Maybe there was a Chainlit app I had you do that was the RAG application for the CS chatbot. You could bring that up and then point this thing to the UI of that, and then be able to run a penetration test on that. That skill in and of itself is going to be useful if you're interviewing for jobs. I guarantee it, especially if they're like, almost everybody is doing AI stuff now. Like, you're going to get hired and they're going to be working on AI stuff. So then you can say, I can also help you secure your AI stuff. And then hopefully you can get in at some of these places. Okay, so with that, I am going to, just let you get started on the labs and the homework. Yeah, hopefully they're fixed. I know people are finding bugs. I just finished it up like an hour ago, so hopefully it's solid. But if you find any issues, just let me know.